Hi, everyone, and thank you, Ben, for first giving me the opportunity to talk on this workshop. It's something definitely new to me, but I must perhaps disappoint the audience first because I'm not going to talk about what was in the Eventbrite topic as a coastal erosion. I'll focus more on an industry point of view, or at least my point of view, and then try to talk about or give some examples of what we're currently doing and our ambitions as well. But before we jump straight into the action, just 30 seconds about us as a company. So we've been around for quite some time, and the last information I have is we have currently 88 offices in 33 countries and more than 14,000 staff. So it's difficult to list all the services that we provide. That's why I didn't put it here. And it's even more difficult to be aware of what's going on in the firm globally. We do have I'm part of the maritime team working in London, but we have maritime or coastal and water related people all over the world. So that was just 30 seconds about us. And trying to focus more on what are we currently doing. And I try to think about simulations, modeling mostly as the topic for this talk. And I decided to split this into various examples going from small scale to large scale. And if we can start with the small scale is just because it's generally more computationally demanding and we're looking at more detail. So I'd start with dual SPH, which a lot of you will be familiar with. This is something that we haven't done. I nicked this off the Duals Physics YouTube channel, but just to illustrate things we are interested in industry, which is things happening very close to the coastline and looking at issues like wave overtopping, so how much water goes over your sea defenses or river defenses, what are the loads on the structures. And so we use, when scenarios get very complex, we tend to use complex methods as well to try to solve them, because otherwise we get empirical formulae and they are what they are. They've been developed for years. Sometimes in some situations they're good, sometimes they're not good enough. In parallel to dual physics, we also use open foam. That's some of my colleagues are more familiar with open foam. We keep an open mind. We all know about the advantages and disadvantages of each one, but it's just to illustrate we also work with open foam. And again, we resort to this kind of numerical methods or software when we have scenarios which are very different from scenarios that have been studied for years and years, and empirical formulas are good enough. And we also use ANSYS on a more ad hoc basis. This is an example of a monopile for a wind turbine, and we were looking to assess the loads on the monopile, but obviously once you got all the secondary steel structures, the drag coefficient, which is in the literature for cylinders, it no longer applies. So we have to resort to some numerical methods to try to make a best estimate. But specifically on SPH, I've tried to highlight here some key issues that I'm aware they've been developed or are under development recently. So first is coupling with our other software, for example, SWOSH, so that we can reduce effectively the domain size of the SPH. So that was, I think, a major breakthrough. I believe you're still working on variable resolution, but that would be also a very interesting advancement. And as a business, as a service, we work a lot with labs such as HR Wallingford to do physical models of various structures, and they can be sort of two-dimensional in a channel, or they can be three-dimensional in a basin. And we're talking about, well, after you build a model and calibrate it and so on, we're talking about 1 hour to do a run. And those cross sections that we can do in duals physics, or the ones that I can do with my computing power, they take like 12 hours to run. So it's not yet. We would like it to be faster, but that's where we are, or that's where I am. Moving a bit along the scale. So we're talking about kilometers now, not meters or hundreds of meters. We do a lot of wave modeling as well. This is an example of a model I've done recently in Newcastle, looking at wave propagation from offshore to near shore, looking at the impact on ferry terminals. And we're talking about 4 to 5 kilometers on a 3 by 3 meter grid. And we're looking to simulate 1 hour in prototype, which takes in my computer, which is, again, not state of the art by any means, 4 to 6 hours. So just to give you a sense of scale. Something that might be more relevant to this talk is, I'm not sure if you heard about this. This is called the State of the Nation approach. It was developed by H.R. Wallingford to tackle this issue of how can we have a better or more accurate design conditions for our structures. And the main point is that it starts from an offshore point where you have data for, and we do some clever statistical analysis offshore. And then because it's not practical to transpose, say, 30 years of data at an hourly time step or 15-minute time step, it's not practical to transpose all of those with a numerical model to near shore. We usually rely on an emulator. So we run, in this case, for example, 600 simulations, and then we establish a relationship, definitely non-linear, between offshore and near shore. So this gets you, for example, from the -50 contour to say -5. And then we rely on another model, which can be a 1D model, for example, SWAN, which takes you then to the toe of the structure or the limit of your flood defense, sea defense. And then we have to jump into another model. In this case, if you're talking about wave overtopping, we might use a machine learning tool, or if you're talking about loads on the structure, we might use SPH, for example. Again, moving a bit more in the scale, so it's no longer 5 kilometers, more like 30 by 30 kilometers. This is modeling, flood modeling. For those who know, this is for those who don't know, this is the River Nene and the wash area, and it's a very flat area. That's why our catchment is huge. Not only the tidal river is 40 kilometers, but the catchment is huge. And we look to advise clients on lots of things, from climate change and sea level rise, and effectively what are the impacts on asset management. And in this case, we were running simulations, which we need to run several tidal cycles to get a stable condition. And it was taking up almost a week to just do one simulation. I'm not sure entirely what computation, what infrastructure was used to run this simulation, but and I'm sure it could be improved, but just to give you a sense of timescales that we're looking at. And finally, and I'm sure this will be, again, relevant to the current talk, is this NAFRA 2, which is the National Flood Risk Assessment, which, according to the Met Office and the Environment Agency, is supposed to be the first cloud-based interactive national flood risk assessment system. And the aim is to combine flooding from 3 sources: from rivers, from the sea, and from surface water, which at the moment we can all calculate or use the model separately. But they don't talk to each other. So the aim is to merge everything together. And also the Environment Agency has lots of small models. So this is what it's talking about from a national scale to property level, if we're talking about resolution. And as I was saying, this is a very simplified scheme of how various Environment Agency models and information on assets and flood defenses might feed into a holistic approach looking at flooding from rivers and the sea and surface water and reservoirs and so on. And if you think about what the future might look like, and we want to add climate change, we want to model scenarios of, breaches of dams or reservoirs, and we want to know damages and monetary impact and duration and probability, we suddenly start to build a matrix with at least these dimensions. And that's why HPC is really critical. Otherwise, we will never be able to deliver on this. And this is a project that's meant to last for 7 years. My company, we were bidding for this with the likes of Airbus. We were partnering with Airbus because Airbus should know a thing or two about data storage and lots of data, handling lots of data. Unfortunately, we were not successful, but I'm sure another company will do good on this. So yeah, as I said, this NAFRA 2 hopes to go from a national scale to property level scale, and it's definitely ambitious. And our gut feeling is that 7 years is not going to be enough to be able to solve this problem because, yeah, it's just too complex at the moment. So I'd like to finish, because I was told I would get 10 minutes, just with some bullet points on conclusions and next steps. So something I've noticed, and not only in my organization, but others as well, is that we are investing very heavily on anything that's digital. So digital here is the key word. If you don't use it 10 times per day, God knows what you're doing. And this investment is not only in recruitment. So we are more and more integrating people with other digital skills in our traditional engineering business, but also investment in infrastructure, which I guess is what was talked already here. And then more and more, we are getting projects that are at a national scale, not only here in the UK, but I can give a couple of examples that we are doing a similar work for Bahrain. So even though it's not a big country, we're looking at a national scale, and also for Hong Kong as well, looking at tropical cyclones and climate change. So it's definitely trending, but we shouldn't forget the small scale, the CFD, looking at 50 meters of coastline with a very intricate geometry that's also equally relevant. And obviously better technology, as we've been discussing so far this afternoon, opens the door to new challenges. And for those who have seen The Mandalorian, the series The Mandalorian, this is the way. And I'll finish with 2 questions, open questions. I'm not expecting an answer right now, or not sure if anyone has it really. But first is, how can we democratize this high performance computing? How can we make the bridge to practitioners such as myself or organizations that deal with engineering, for example, so that engineers can learn a bit more about computer science, because there seems to be this gap that we have some people who know something and some people who know something else, but there's a gap in the middle. So that's one question. And the second one, which I think we are doing something about, is to improve the collaboration between research centers and industry, because at the end of the day, I think there's synergies that can come from this collaboration. So thank you very much.
Okay, thank you very much. That was very good. So very helpful. Right. So we got one question from Stephen.
Hi. So it was more a response really to your open question, your first open question, how can we democratize high performance computing? I think it's a really good question. So going back to the opening discussion with Simon McIntosh-Smith, he talked a lot about the technologies that are underpinning, hopefully, the exascale future. So the use of cross-platform technologies. So libraries like SQL, for example, rather than focusing on vendor-specific solutions. For some reason, during the petascale era, vendor-specific solutions have won out. There's no two ways about it. As we move to exascale, I think that has to change. And if that changes and the vendors are no longer able to drive everything, then that starts to automatically democratize things, because then industry can focus on a technology like SQL or a technology that is non-vendor specific, and all of a sudden the vendors need to make sure that the technologies that bridge everything all work well. I mean, it's a nice idea, and it's one that should have probably taken off during petascale time. So I hope that's something that's going to really take off as exascale pushes forward. And the landscape that you saw Simon present points to the fact that no one vendor can become dominant this time.
Okay, I had a question actually. So you presented how you guys are thinking about answering some of these big problems using a mixture of approaches across scales and across different model types. Given that exascale is just around the corner, how feasible is it that, that a company such as Arup will actually invest in using an exascale facility?
Yeah, I think it's very likely. I just mentioned a few applications, but I know that people in the geotechnics team, for example, I think they are renting one of the best machines in AWS to run continuously some slope analysis for the whole of sub-Saharan Africa, something like that. We would be keen. We would be keen to get involved and at least be aware of what's out there.
Okay, that's very encouraging to hear. I'm glad, because many engineers, they sort of want an iPad response. Okay, but any more questions before we move on to the next?